Okay, so we're also gonna have a quiz next time on quadratic forms, and it's basically we've discussed this now, and it is basically continuation of diagonalization and effect of orthogonal diagonalization. So I'm going to just work out one example, but okay, guys, this is a review for a quiz, and you should not just listen to this and look at this. You should try it yourself. So before you actually really watch to the video, at each given time, pause the video and try to work it out for yourself. Okay, and perhaps not the whole problem, because you want to make sure that, for instance, you have the right eigenvalues and so on. So go step by step, do the step and say, okay, am I right so far? Look at the video, and then, and this is the best way for you to learn. I'm saying this because we're going to shortly have our big quizzes, the two big quizzes in the last week. I'll say somewhere more about that in other videos. That will be somehow our final. And for those things, you have to be a little bit more prepared, because you're going to have a little bit more time, but not 4 times as much, but you're going to get 4 times as many questions. I mean, you're going to get 4 questions instead of 1 question in these big quizzes. So you're going to have to be able to do this a little bit quicker. Okay, and also this means that you should prepare yourself in advance. I know many of you, I think, what they do is when they get a quiz, they go look at this review and then do the quiz. That's not how you're supposed to be doing this, because that means that you won't have the time on the big quizzes to do all this. Okay, so, but I will discuss about the big quizzes somewhere else. Let's now look at this particular example, and I want to look at the following quadratic form here. We have 3, I'm going to write it x1 square plus 2x1 x2 plus 2x1 x3 plus 4 times x2 x3, and that's it. Sorry. So this is our quadratic form. Okay. So I remind you, a quadratic form is basically a polynomial in, well, this time 3 variables of degree 2, and only degree 2 variables, only degree 2 monomials. Okay, so step 1 is this. To this we associate a symmetric matrix. What is a symmetric matrix? Well, we know what goes onto the diagonal. Again, it helps if you, let me do it in a bit slightly different color, if you kind of mark the columns and rows by the variables, then you see where what goes. So of course on the diagonal goes the square terms, and there's a 3 here, but there are no other ones. That means a 0 and a 0 there. Now this is an x2, x1, or x1, x2. They are both there. And here we have to equally divide, so we get a 1 here and a 1 there. That's this coefficient 2 here. This coefficient 2, where does that go? Well, it corresponds to this position and as well as this position. So again, dividing half that's where it goes. And then this corresponds to x2, x3, right? x2, x3, so there, or x3, x2, because that is the same product. Now we have 4, we have to divide it equally, so we get 2 and 2 here. Okay, so the question, sorry, yeah, I gave a quadratic form. I should have formulated the question. The question is here, find a quadratic form, find the change of variables so that this quadratic form becomes, without cross terms, becomes a diagonal quadratic form. Okay, all right, so that's step 1, we have the matrix. Step 2, and this from here on, it's kind of exactly orthogonal diagonalization, I'm sorry. So again, I'm just saying, stop here and try to work it out, and then see whether it's correct. So characteristic equation. So we have to subtract lambda from the diagonal. So here we have really no zeros. So expanding might be not always the best thing to do. So I'm going to show you how you can do this by using pivots. And remember, in determinants we don't need to have the pivots really on top. We don't need an echelon form. So we can use this one to make a 0 on the first 2. So in row 1, that means that's the more annoying one, because it will depend on this number here, right? We have to subtract that, or in other words, add this many times row 3 to it. Lambda minus 3 will cancel with 3 minus lambda, right? Row 2 is much easier, that is row 2 minus row 3. Okay, so what we get? So we have to multiply this with lambda minus 3 and then add up to the top, so that's a 0 there. Then I get 2 times lambda minus 3 plus 1, and I get minus lambda minus 3 plus 1. Okay, so I multiply each of these elements with lambda minus 3. That's a 3 here. And add it to the first row. Okay, in the second row I get a 0 here. We can now multiply this with negative 1 and add up. So we get negative 2, negative lambda. And here we get 2 plus lambda. Okay, make sure I didn't make a mistake here. Okay, I think I'm right. And then of course we have 1, 2 minus lambda. Now we can use, now we have these zeros here, so we're going to expand along column 1. That means we're going to have this 1, which I don't need to write, and then the cofactor is 2, well, I could work this out, it's 2 lambda minus 6 plus 1, so minus 5. Very careful with the negatives and so on here. The other one is minus lambda squared plus 3 lambda plus 1. I get minus lambda minus 2 and lambda plus 2. Now that's a 2 by 2, which I always work out, just product of the diagonal elements minus the product of diagonal elements. There's a lot of minuses here always, so be very careful. Okay, let's expand the first one. Foil it, 2 lambda squared plus 4 lambda minus 5 lambda minus 10. And then we have a minus minus here, so what I do is distribute this minus over these minuses, so this becomes all pluses. So this is a plus, okay? That makes it a little bit easier to work with. So now we have here a minus lambda cube plus 3 lambda squared plus lambda, that is multiplying with this guy. Now multiplying with this guy, we get minus 2 lambda squared plus 6 lambda plus 2. Okay, let's combine like terms. All this is 0. We have a minus lambda cube. This is this one. Then we have a 2 lambda square minus 2 lambda square. What else? There's a 3 lambda square here. Was it a 3? So yeah, there's a 3. So altogether is a 3 lambda square. Okay, so these are cancelled out. So okay, yeah. So they are done. Let's scrap them out. So 4 minus 5, that is minus 1. Oh, that's completely gone now. So we get 6 lambda. And then minus 10 plus 2 is minus 8. Okay, and we rather start with a positive, the highest degree term with a positive quotient 1, so that's what I'm going to do now. Now this is third degree, and I told you this is of course the annoying part here, that is that we have to find the roots of a third degree polynomial might be very difficult, and because we have to factor it. I normally give you something where the factoring is not too difficult, but here we have, what are the ways that we have here for factoring? Well, basically the one way that we really can do is try, and what we try for are the divisors of 8. Now 8 has many divisors, right? So we can have so the divisors of 8 are plus or minus 1. Don't forget there are always negative divisors too, plus or minus 2, plus or minus 4, and plus or minus 8. Okay, so we have to try all of them to see which one might be a possible solution. Now, I start with the first one. I'm lucky because if I plug in 1, I get 1 minus 3 minus 6 plus 8, that is 0. So I see that lambda equals 1 is a solution. That means that, what does this mean is that lambda minus 1 divides this guy. So I can do long division of this guy. Now, unfortunately, I always... Normally I ask somebody to tell me where to write everything, and I'm not, so, okay, I'm gonna do the long division. I wanna do it my way, but then that's not helpful for you guys. I'm trying to remember where you guys put it. I know that on top comes the answer. Okay, that's where you guys put the answer. But I don't remember now anymore whether lambda minus 1 goes there or goes there. Oh boy. I think it goes here, right? I'm sorry if I put things in the wrong place, but I have to divide lambda minus 1. So how many times does lambda minus 1 go in lambda cube? How much goes lambda into lambda cube? Lambda squared times. And so that gives me lambda cube minus lambda square. Then I subtract. Okay, so that means actually a minus here, a plus there. So I get minus 3. So minus 2 lambda square minus 6 lambda, bring that guy down. How many times does lambda go into this guy? Well, minus 2 lambda times. Okay, so I get, let me get rid of this line here. I get, now I multiply minus 2 lambda times lambda minus 1. So I get minus 2 lambda square plus 2 lambda. And again, I subtract. Subtracting means that this becomes a plus and this becomes a minus. So we get minus 8 lambda plus 8. How many times does lambda go into minus 8 lambda? Minus 8 times. So again, I get multiply now minus 8 lambda plus 8. I subtract, and of course I get remainder 0. So this is my quotient. So what this means is I know now that this factored as lambda minus 1 times lambda square minus 2 lambda minus 8 equals 0. Okay, this is the long division, tells me how to get this. And I'm sorry, I apologize if I did the wrong division in a different way. This is still not how I would do it, but okay, I'm not going to show you. Anyways, this is what it is. And so now we have to further factor this, but quadratics are locally easier. And so we need two numbers that, okay, I see it here, lambda minus 4, lambda plus 2, right? Because that adds up to negative 2, yeah, okay. So this is the full factorization. So I get lambda equals 1, lambda equals 4, and this gives lambda equals negative 2. Okay, so these are the eigenvalues. Good. So the matrix, I'll write the matrix again here, was 3, 1, 1, 1, 0, 2, 1, 2, 0. Okay, so now step 3, I guess I'm already, the eigenspaces. Well, let's start with lambda equals 1. That means we're going to subtract lambda. So remember, I don't write it that often, but this is really what we do, right? We have to calculate the determinant of this matrix. Not determinant. We have to look at this matrix and find its null space. Okay, find the basis for its null space. Okay, so that means we subtract 1 from the diagonal. So here now lambda is 1. So we get 2, 1, 1, 1 minus 1, 2, and 1, 2, negative 1. Okay, let's switch around these two. Because, sorry, these are actually matrices, not determinants. Because we are now dealing with matrices and not determinants, we do need echelon form. So I have to get my 1 in the right position. So I'm going to do row 1 interchange with row 2. So I get 1 minus 1, 2, and then I 2, 1, 1, and 1, 2, minus 1. Okay, this is now a pivot that I can use, and I do row 2 minus 2 times row 1, and row 3 minus row 1. This gives me 1 minus 1, 2. That gives me, so minus 1 minus 2 times, so this is 0, 3, minus 4 plus 1 is minus 3. And now instead I do minus 1, that's a 0, minus minus is 1 plus 2, that's 3, and minus 2 minus 1 is minus 3. Okay, let's see that I can divide row 2 by 3. I can do this also in row 1, in row 3, but it's not really necessary. Because of course, because the fact that these two rows are the same, I already know that one of them is going to go away, right? So, but it's dangerous to write it at the same time, because you have, if you would write here also the next operation. What is the next operation? Okay, so the next operation is row 3 minus 3 times row 2. If I would write it here, I could make a mistake. Then it depends. See, I would then think, oh, I have to, if I do it up there, I would not write row 3 minus 3 times row 2, I would do row 3 minus row 2, right? So they get zeros from here. But that's not allowed, because I have already, before I do this row operation, I have done this row operation, which changes row 2. So you always have to be very careful with this kind of, that you don't that you don't mix row operations where a row has all of a sudden changed. Okay? So, going back to what I'm doing, this is now, and now I get 0, 0, 0 here. Okay, we have our pivots, but these are the pivots, but we need a 0 on top of this, the second one. So we're gonna do one more operation, row 1 plus row 2. We get now 1, 0, 1. And then we get 0, 1, negative 1, and the rest is the zeros, so I will not write those. Let's see. x1, x2 are pivot, and x3 is the free variable, so we get x1 from, let me write it up again, x1, x2, x3. What is x1? Well, from this equation we see it's minus x3, from this equation we see x2 is equal to x3, and x3 always equal to itself. So x3 minus 1, 1, 1. Now we have to normalize. So we need the norm of this guy, minus 1, 1, 1. That is square root of 1 plus 1 plus 1, so square root of 3. And so our basis is minus 1 over radical 3, 1 over radical 3, 1 over radical 3. Okay. Next eigenvalue is, I think, what is it? 4. Let's do 4, okay. Lambda is 4, so now I'm going to subtract 4 here from the diagonal. This is going to be, well, I'll copy the matrix again. 3, 1, 1, 1, 0, 2, 1, 2, 0. So I subtract 4, so now I have the matrix minus 1, 1, 1, 1, minus 4, 2, and 1, 2, negative 4. Okay, I can switch to rows, or I can do, perhaps a bit easier is to replace row 1, but it's negative. So I get 1, minus 1, 1, 1, minus 4, 2, 1, 2, negative 4. And now I can do row 2, minus row 1, row 3, minus row 1. I get 1, negative 1, 1. So here now we do subtract. So minus 1, so that's a 0. Plus 1 minus 4 is negative 3. Minus 1. Sorry. Oh, I see what I did. I forgot the negative sign here, right? I have to change both negative signs here, yes. Minus 1, so this is 3. Okay, that's correct. And now the next one is 0. I get 2 plus 2 is, sorry. Minus 1 times minus 1 is 1 plus 2, that's 3. Minus 1 minus 4 is negative 3. Okay. So I'm going to divide row 2 by minus 1/3 again. Get 1, minus 1, 1, 0, 1, minus 1, and then 0, 3, minus 3. And it's now clear that the second row is going to disappear. The third row, I mean, row 3 minus 3 times row 2. That's going to give me 1, minus 1, 1, 0, 1, minus 1, and then this is 0, 0, 0. Now, this guy has to still be 0 because it's above this pivot, so I have to do row 1 plus row 2. So this is there, right? Okay, so I'll get 1, 0, 0, 0, 1, minus 1, 0, 0, 0. Well, I don't have to write that. This means x1 and x2 are my pivots, and x3 is the free variable. So x1 is 0. I'm sorry, let me write that this way. x1 is 0. This equation tells me x2 is equal to x3, and x3 always equal to itself. So x3, 0, 1, 1. The norm of this guy, 0, 1, 1. So we have to normalize, right? Is square root of 0 plus 1 plus 1, so square root of 2. And so the basis is 0, 1 over radical 2, 1 over radical 2. And then finally, what was it? Last one was negative 2. So I'm going to have to subtract negative 2 from the thing again. So that means actually adding 2, right? So we're going to do plus 2, plus 2, plus 2. So the matrix becomes, I hope you trust me, that the matrix is then equal to, so this is lambda equals negative 2, 5, 1, 1, 1, 2, 2, 1, 2, 2, right? Double checking. 5, 1, 1, 1, 2, 2, 1, 2, 2. Yeah, I don't know. This is a plus that kind of got very stickish. Okay, so this is it. Right, let's swap row 1 with row 2 to get a 1. 1, 2, 2, and then we have 5, 1, 1, and then 1, 2, 2. Okay, then with this one I do row 2 minus 5 times row 1, row 3 minus row 1. I get 1, 2, 2, so negative 5 times, that's a 0. Negative 10 plus 1 is negative 9, negative 10 plus 1 is negative 9, and the bottom row is just 0. Okay, we're almost done. We can divide row 2 by minus 9. Get 1, 2, 2, 0, 1, 1, 0, 0, 0. And so what we need to do is make this guy 0, so we do row 1 minus 2 times row 2. I get 1, 0, 0, 0, 1, 1, and then the 0 row. So, okay, this means x1 and x2 are again the pivot variables, x3 is the free variable. So we get x1, x2, x3. x3 is always equal to itself. From this equation, x1 is 0, and from this equation, x2 is minus x3. So we get x3 times 0 minus 1, 1. And then if we take the norm, so we normalize 0 minus 1, 1. That is square root of 0 plus 1 plus 1, so square root of 2. And so the basis that we get is 0 minus 1 radical 2, 1 radical 2. Okay. Just let me double check here, I hope. I have a little suspicion here that I still have, remember I made this negative sign mistake here, and I think I still haven't copied that, right? Because I didn't do anything here, so this should be a negative one. This should be a negative one, right? Okay, and so only now I'm changing row 1, and what I do is no, still not. It's this spot I changed one by adding them. And so this is not 0 but negative 2. I'm sorry, I apologize for that. So let's see here. Yeah, the reason that I know this is because I actually calculated beforehand, and I remember that something else I got. Yeah, it's very tricky. You can very easily make mistakes here. So what we have is this here. So x1, x2, x3. Well, x1 is 2 times x3. X2 is x3. All right. So this is this 2x3 comes from now, right? And then this gives me x1 is x3, and x3 is equal to itself. So I get actually this basis factor and the norm of this, so normalize. That is minus 2, 1, 1. So this is square root of 4 plus 1 plus 1, so there's actually a square root of 6. And so the basis that I get is minus 2 radical 6, 1 radical 6, 1 radical 6. Okay, so step 4, I guess. We are kind of almost there because we can write down what P is and we can write what D is. So in the order that we worked it out, I think it was 1, 4, and negative 2, right? Let me double check, yeah. Okay. So that is going to be our diagonal matrix. So what is P now? Well, P is the corresponding basis vector that we have. The first one was this guy, minus 1 over radical 3, 1 over radical 3, 1 over radical 3. Then we had this one that I first had calculated wrong, so minus 2 radical 6. So I have to 1 over radical 6 and 1 over radical 6. Okay, sorry guys. Just wanna minus the minus 2. This is my matrix, sorry, yeah, let me go back here. This is my matrix, I subtract 4. Still a bit with this lambda equals 4 bugs me. 2, 1, 2 minus 4, I did that correctly, right? And then, okay, then I multiplied with negative 1 and I forgot this negative sign, so that's, now I repaired that. Right, and that's, and then here I added these things, so I get negative 2 here. So I wonder now whether I made a mistake in the first one. See, what my issue is here, this here, so I have already these two. I know that these two have to be orthogonal, but if I add them up, if I take the product of both, I get 2 plus 1 over radical 18, which is not 0. So there's something wrong, there's a sign wrong. Did I copy something wrong here? Let me see, did I do this one right? So I have to subtract one of the diagonal. Okay, that's also correct. Okay, the last step here, was that correct? I added 1. That's what I had the last time too, so I got the same answer. Okay, so let me put in the last one here, this one here, that would have been 0, minus 1 radical 2, 1 radical 2. Now that one is okay, is orthogonal to both of those, so those two are okay. There's something with the sign here that is off. Oh yeah, now I see it. Okay, here, 2x3 and I write minus 2. Where on the earth come this minus 2 from? So it is a positive 2 here. Okay, so this is a positive 2. Now we are good, because now if I multiply, if I take the product of these two columns, the dot product, that is basically multiplying the corresponding elements, right? So multiply these two, or multiply these two, or multiply these two, and then you get negative 2 plus 1, and they all have denominator radical 18, so that's 0. Yeah, okay, this is correct. I'm sorry about that. Yeah, it's very quickly, but you see, this is why you can always double check, do I get an orthogonal matrix? Alright, so keep double checking this. Okay, so where are we? So step 5 is basically now just giving the conclusion. Namely, this says that if we do the change of variables given by this matrix, this complicated matrix perhaps, we don't need to write it out, then we know that the new quadratic equation will have these square terms, so y1 squared plus 2y2 squared minus 2 times y3 squared. Okay. Notice, by the way, that at this point here, all the way in the beginning, where was this? Once we had the eigenvalues, we already knew how the diagonal matrix will look, the diagonal quadratic form will look like, the quadratic form without cross terms, because that's the only thing we needed to know. Because we now know, we know already what D is. So we could have written down this already over there. The thing we didn't know yet is what is exactly the change of variables. What is the matrix that tells us how to change our variables? And that's the thing that why we needed to do the rest of the calculation. And when I ask this question on the quiz or on the final, I always want you to do also calculate the matrix P that gives you the transformation, the substitution of variables. Which, by the way, is not a simple thing, right? So if you would work this out, so you would have to multiply. So this product here is x1, x2, x3, right? You see that so this would be, for instance, y1 is equal to minus 1 radical 3 x1 plus 2 times radical 6 x2 plus 0 times x3. You see, it's a kind of an ugly substitution, right? Because you have these radicals in there, but that's the inevitable. Okay. All right. So that's the quiz. That's the preparation for the quiz. I'll promise you, I'll give you a little bit easier characteristic equation, but all the rest you have to do too.